Okay, my friends, so today we will be talking about exponents, scientific notation, all that good stuff. So let's talk exponents first. So if I give you something like 3 times 3, right? We know that that's equal to 9. Fine. But let's say I give you 3 times 3 times 3, which we know is 27. Nobody wants to write 3 of these. It's kind of a lot. So you can write this as 3 to the third, right? Which is equal to 3 times 3 times 3, which we also know is 27. Which means this can be written as 3 squared. Cool? Any questions? Fantastic. Okay. So the first thing you'll want is let A be a number and B be an integer. Actually, let's call it J. A to the power of J is equal to A times itself J times, okay? Okay. Okay. We all cool with this? Okay. Great. Now, let's say I give you 3 squared times 3 to the fifth, right? What does this mean? This can be written as 3 times 3 times 1, 2, 3, 4, 5, right? But based off of property 1, right, this is our property 1, right, we can actually combine it down to one piece, okay? That means you can count. So, of course, something worth noting, A to the power of 1 is just A, okay? So, for example, 3 to the first is just 3. It's one of them, okay? One of them as like a vibe, right? Okay. Now, suppose I ask 3 squared times 3 to the fifth, right? If we were to do that, and I'll split our piece into 2 sections, right? 3 squared is the same as 3 times 3, and we're going to multiply by, 3 to the fifth, which is 3 times itself 5 times, right? So 1, 2, 3, 4, 5, right? And we're going to count. There's 1 of them, 2 of them, 3 of them, 7 of them. Which means we know that this is going to be 3 to the 7th. Okay? Capiche? Okay. And so this gives us the second property. Let A be a number and J and K are integers. Okay? That means we know that A to the power of J times A to the power of K is equal to A times A times A, J times A times A, and another K times, right? And if you count all of the A's together, you end up with A to the J plus K on the exponent, okay? Don't ever tell me that it's A to the J plus K, like that. Don't do that. Up here, you're counting how many A's, how many of that same number you're multiplying together, okay? All right, I think this seems reasonable. So if I ever tell you, expand it for me, tell me another way to write, I don't know, 3 to the 7th times 3 to the 4th, I want you to write it out like this, okay? So, now suppose I ask, what is 3 to the 7th divided by 3 to the, let's pick a good number, 3 to the 5th, right? 3 to the 7th divided by 3 to the 5th. What's another way to write this? Well, you can write the top as 3 times itself 7 times. So 1, 2, 3, 4, 5, 6, 7, right? And on the denominator, it's 3 times itself, 5 times. 1, 2, 3, 4, 5, right? Now let's take a pause. If I ask you, oh, what's 12 divided by 6? You're going to tell me it's 2. Why? The long way to write that is 6 times 2 over 6, yeah? And there's 2 ways you can go about it from here. You can either say, oh, this cancels out into 1. Do not ever tell me that 6 over 6 cancels out to 0, okay? Don't ever do that. Or another way to say this is this becomes 6 over 6 times 2, which again, 6 over 6 is equal to 1, right? And that gives you 2, yeah? And so in that same way, you can work it out like this. I like to pair them up, so I'll go 3 divided by 3 is 1, and you have to divide 1 on the top and 1 on the bottom, okay? You can't be like, oh, don't do that, okay? Pairs. This has a buddy, this has a buddy, this has a buddy, this has a buddy, and this has a buddy. And this should leave you with 3, and there's 2 of them, 3 squared, okay? And so this tells us another property. Again, a is a number, j and k are integers. A to the j divided by a to the k is equal to a to the j minus k. If I ask you to verify, I want you to do it like this, okay? All right, let me ask you another question. You know what, I'm gonna have you work this one out for grade school purposes, all right? I'm gonna have you say, prove to me that a to the 0 is equal to 1 using property number 3, okay? You can use an example for this. You can say, oh, j is some arbitrary number, or j is 7. That's fine, okay? I just want you to explain to me why a to the 0 is equal to 1, okay? And 2, another grade scope question, or I guess probably number 5, is a to the negative j is equal to 1 over a to the j. I want you to prove this to me and send it to Gradescope. Okay. Hint, you can use properties 3 and 4. Okay. So to sum it back up, our property number 1 are properties of exponents. And please, for the love of God, I know you're going to want to memorize this. Don't do it. You will memorize it wrong. Understand why it works and do it enough that it becomes common sense. That's when we memorize things, yeah? Oh no. Okay? Okay. So our properties are as follows. A to the j is equal to a times a times a, j times. Okay? So a squared, a times a twice, a to the 4th, a times itself 4 times, so on and so forth. All right? 2, a to the j times a to the k is equal to a to the j plus k. All right? 3, a to the j divided by a to the k is equal to a to the parentheses j minus k. 4, a to the 0 is equal to 1. Again, don't memorize it. Figure out why it works first. And finally, is that enough space? No, it's not. And finally, a to the negative j is equal to 1 over a to the j, just like that. All right? So these are the main properties of exponents I want you guys to know, understand, and be able to do in your sleep. But I lied. There's another one. Let's say I give you 3 to the 5th, right? And then I square it. What does that mean, right? Well, like we said, this is going to be 3 times 3, 5 times. 3 times 3 times 3, 5, and then you square that. What does it mean to square something? It means you take whatever's being squared and you multiply it again to itself, right? Which means you have 2 sets of this. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, like that. And now we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and this gives me 3 to the 10th, which just so happens to be 5 times 2. And so that last property we have, oh no, is a to the j to the k, like that, okay, is equal to a to the j times k. And I want you to justify for grade scope as well. All right? And that's properties of exponents. It's pretty straightforward. Yeah. Oh, before I forget, this I need to crop in actually. This is very important. This is provided a does not equal 0, and this is also provided a does not equal 0. Oh, and a to the 0 equals 1, provided a does not equal 0 as well. Okay? Cool. Oh, and one more important funsies, oopsie daisies property. 7. We have a times b to the k is equal to a to the k, b to the k. I want you to explain why to grade scope. All right. So, as a hint, you can use property. You can use property 6. And of course, if there are other properties you find useful for this, go crazy, I guess. All right? Okay, I'm like obligated to tell you about, but I personally don't care for, is scientific notation. Scientific notation. And Sino requires a couple properties that I will list out for you. A number expressed in Sino, is of the form a, actually I'll do it in a different color. Please don't use x's, okay? A times 10 to the n, where 1 is less than or equal to the absolute value of a, which is less than 10, and n is an integer. Okay? So, for example, let's say you want 921 in Sino, right? Well, 921 is too big. So here's what you're going to do. I hate this method, but it works for you guys. So 921 can be written like this, right? 921.0, right? Decimal places, sig figs, all that baloney. Okay. Well, if we want our number to be less than 10, right? You go whoop, whoop. You move over 2 decimal places, right? But moving over 2 decimal places means you divide it by 100, right? So that leaves you with 9.21 times How many decimal places did you lose? How many times did you divide by 10? Twice. So 921 times 10 squared. Okay? That's it. Oh, but Amanda, what if my number's too small? I got you. Let's say the number is 0, 8, 21. Too small. That's okay. We're going to sino that thing. We're going to go 1. That's still less than 1, I fear. And 2. 1, 2. Okay. That leaves me with 8.21. And how many times did I multiply by 10 to get the number to be bigger? Twice. It's going to give 10 squared. Oh, but Amanda, how do you add sino? There's a lot of weird ways to do it. I believe in factoring. This is a factoring-friendly home. So let's do an example. Say we want to add 9.13 times 10 to the third plus 1.6 times 10 to the negative 1. Okay, couple options. You can either make this number turn into negative 1, or you can make this number turn into positive 3, or the exponent being positive 3. Both are fine. They both kind of suck. Right? Or you can pick a number in the middle. You could bring it to 0, I suppose, right? Here's what I would do. Personally, I actually expand it like a weirdo. So I know that this is equal to 9130, right? Because 1, 2, 3. And I know that this is, let's see, if this is moving to the left, to the right, then this is moving to the left. So this is plus 0.16. I personally expand and then put it back to sino later, because I'm very bad at scientific notation. I'm very bad with lefts and rights. Okay, and this is going to be 9130.16. That's not in scientific notation yet. Okay, how many places do I have to move? 1, 2, 3. This becomes 9.13016 times 10 to the third. Magical. Yeah, all sorts of fun ways to do it. Read the textbook if you want other ways. This, in my opinion, is my tried and true way. I never mess this way up. Does it take forever? Yes. And that's it for scientific notation. Let's do some problems. Oh, so here are the grade scope workbook problems. Instead of giving an example for number 8, we're on page 91, by the way. Instead of an example, I want you to prove it. And you can use property 6 as well, okay? I also want you guys to do numbers 10 through 16, 24 through 28. Actually, instead of through 28, I want it through 32. And follow their instructions. Their instructions are good. I want 37, 39, 41. I want 51 through, let's say 56. '60, 61, or 60 through 62. It feels like a lot of these problems are actually pretty quick once you get the hang of them. 64, 67. Go on, giggle, do it. And 80. For scientific notation, I don't think the practice problems are worth doing, but for your sanity, I suppose, I will not be collecting this, okay? For your sanity, I will, when I quiz you on it, very small portion, okay? For a not grade scope, do for your sake. Like if you did just fine on this on Alex, don't do these. I want you guys to do number 84. Actually 84 through 89. And yeah, that's it. Okay, bye.